Now let us check whether or not the shortest path problem exhibits the optimal substructure property. So say we have a graph like this, directed graph, and say we represent the graph using VE, and say we have a weight table like this that maps each of the edges to the corresponding real values. And say we actually have a shortest path P, which consists of these nodes V0, V1 all the way to Vk. So all of these are vertices in the shortest path. And say, for example, that in this path from 0 to V0 to Vk, we have two intermediate vertices, I and j, such that the vertex I comes before vertex j and vertex j comes before vertex k, and I comes after the first vertex. Then the question is, if this path 0 through k is the shortest path, then the subpath from I to j, is it also the shortest path from vertex I to vertex j? In other words, if we have a solution for this entire problem, can we say that our solution also contains within itself a solution for one of the sub-problems? Now to check this, let us decompose our path P in terms of I and j. So our path P can be written as path from vertex 0 to vertex I plus path from I to j plus path from j to k. So this implies that the total path cost WP can be expressed as the path cost of this path 0i plus the path cost of this path ij and the path cost of this path jk. Now for contradiction, let's assume that this path pij is not the shortest path, not shortest path. And let's say there is another path p dash ij, which is actually the shortest path between I and j. This implies that there is another path cost wp dash ij, which is actually lesser than this path cost wpij. So since pij is not the shortest path and wpij is not the minimum path cost between I and j, instead this is the shortest path, that means there is another path from 0 to k which goes through ij, which can eventually give us a shorter path between 0 and k. So instead of taking this path wpij, here I could simply take this path p dash ij and get a lesser weight of the total path, right? So in other words, our new weight, let's say w dash p0k from 0 to k, would be less than our w by taking path 0k. This is because we have found a shorter path between I and j. So this contradicts what we started, that is p is the shortest path, right? So to go back where we started, that means our assumption that pij is not the shortest path is wrong. So that means pij must be a shortest path, which means that if we have a path, shortest path between 0 and k and ij are the intermediate vertices, then the path from I to j will also be the shortest path between I and j. So this proves the optimal substructure property of the shortest path problem.